You spend thousands on a backup power system. The lights come back on. The refrigerator starts. Your internet reconnects. And for a moment, it looks like you made the right decision. Then, sometime after midnight, everything shuts down. The battery wasn't necessarily faulty. The seller may not have lied to you. You simply bought the wrong kind of power. And that happens because most people choose backup power using the largest number printed on the box. 2,000 watts sounds powerful. 5,000 watts sounds even better. But neither number tells you whether your refrigerator will still be cold in the morning. By the end of this video, you'll know which appliances you can protect, how much battery capacity you need, and whether your home is better suited to a portable power station, a battery and inverter system, a generator, or a complete whole home solution. But before looking at products, you need to answer one question. What are you actually trying to protect? Because I want backup power for my home can mean several completely different things. You might only need your router, a few lights, and your phone chargers. You might work from home and need a laptop, monitor, and internet connection to survive an 8-hour outage. You might need to keep food refrigerated overnight. Or you may want the entire house to continue operating as though the power never disappeared. Those are 4 different problems. Buying one system to solve all 4 is how your budget begins packing its bags. So start by dividing your appliances into 3 groups. The first group contains essentials. These are the things you genuinely need during an outage, perhaps your refrigerator, internet router, essential lighting, communication devices, or medically necessary equipment. The second group contains useful appliances. A television, laptop, fan, or small kitchen device might belong here. The third group contains heavy loads. Electric kettles, heaters, air conditioners, water pumps, ovens, and similar appliances can demand a lot of power. You don't need to permanently ban those appliances from your home. You simply need to decide whether they deserve access to your backup battery. Because if your refrigerator is trying to protect a week of food while somebody turns on a kettle, the kettle may win that argument surprisingly quickly. Once you have your appliance list, you can calculate the first number that matters: watts. Watts tell you how much power an appliance needs at a particular moment. If 4 lights use 10 watts each, they require approximately 40 watts while they are operating. If your router uses 15 watts, it adds another 15. If your laptop charger draws 60 watts, your combined load is now approximately 115 watts. This total helps you choose the output of the system. If the appliances need 500 watts at the same time, you need a system capable of delivering more than 500 watts continuously. But this is where motors make the calculation more interesting. A refrigerator, pump, or air conditioner may use one amount of power while running and demand a much larger burst when its motor starts. That brief demand is commonly called starting or surge power. So a system can appear powerful enough based on the appliance's normal running load and still shut down the moment the compressor tries to start. That means you need to check 2 output figures. The first is continuous output, how much power the system can keep delivering. The second is surge output, how much it can deliver briefly when a motor starts. Check the appliance label, manual, or manufacturer information rather than trusting a universal estimate. 2 refrigerators that look almost identical can behave very differently when they start. Now you know whether the system can run your appliances. You still don't know for how long, and this is where watt hours enter the story. Watts describe power at a moment. Watt hours describe how much energy is available over time. Think of watts as the width of a water pipe and watt hours as the amount of water in the tank. A wide pipe can release a lot of water quickly, but if the tank is small, the excitement ends early. Imagine your essential loads require the following energy during a 10-hour outage. Your router uses 15 watts for 10 hours. That's 150 watt hours. 4 efficient lights use a combined 40 watts for 5 hours. That's another 200 watt hours. Your laptop averages 60 watts for 4 hours. Add 240 watt hours. Now imagine your refrigerator consumes an estimated 600 watt hours across the night as its compressor cycles on and off. Your example total is approximately 1,190 watt-hours, but buying a battery advertised at exactly 1,190 watt-hours would leave no room for conversion losses, unexpected use, temperature, battery aging, or that one person who decides midnight is the correct time to make toast. The energy stored inside a battery isn't always identical to the energy that reaches your appliances. The inverter and other internal electronics consume some of it. For an early estimate, you can divide your required appliance energy by the expected usable delivery factor provided by the manufacturer or supported by reliable testing. Then add a sensible reserve. If you use an illustrative delivery factor of 85%, those 1,190 watt-hours become roughly 1,400 watt-hours of required battery capacity. Add a 20% reserve and your target moves closer to 1,700 watt-hours. That doesn't mean every home with a refrigerator needs exactly 1,700 watt-hours. Your refrigerator, usage pattern, and outage length may be completely different. The point is that you calculate from your appliances upward. You don't begin with a product and hope your home politely adjusts itself to the box. Now you can compare the main types of backup power. The first is a portable power station. This is the simplest battery solution for many homeowners. The battery, inverter, charger, and outlets are contained inside one unit. You charge it from the grid, compatible solar panels, or another supported source, then connect selected appliances directly. A portable power station works well when you need lights, internet, phones, laptops, a refrigerator, a television, or a small group of carefully selected appliances. It's quiet at the point of use, doesn't require fuel while discharging, and can usually be moved between rooms. But portability creates limits. You still need to connect appliances to it. It may not operate your home's existing wall circuits without approved additional equipment, and larger units can become portable in the same way that a suitcase full of bricks is technically luggage. The second option is a separate battery and inverter system. Instead of placing everything inside one portable unit, the battery bank, inverter, charge controller, and other components can be selected separately. This gives you more flexibility. You can build a larger system, expand its battery capacity, and connect dedicated home circuits when the system is designed and installed correctly. This may suit you if outages are frequent, you need more appliances, or you want selected circuits to receive backup automatically. But flexibility also introduces complexity: battery voltage, inverter compatibility, cable size, overcurrent protection, ventilation, earthing, transfer equipment, and local electrical requirements all matter. This is where a qualified installer becomes part of the product. If a system connects to your home's wiring, don't improvise the connection and never try to power the house by feeding electricity backward through a wall outlet. Your backup solution shouldn't become the emergency everyone else needs backup from. The third option is a fuel-powered portable generator. A generator can be practical during long outages because you can continue producing electricity as long as you have the correct fuel and can operate it safely. It may be better suited to heavy loads, extended outages, or locations where solar charging is unreliable. But the trade-offs are real. You need fuel, you need maintenance, you get noise, and you produce exhaust containing carbon monoxide. A portable generator must never operate inside your home, garage, basement, shed, or another enclosed area. Opening the door doesn't make an indoor generator safe. Current US safety guidance says portable generators should operate outside, at least 20 feet from the home, with the exhaust directed away from doors, windows, and vents. You should also have working carbon monoxide alarms. Local guidance may differ, so follow the manufacturer's instructions and the safety rules where you live. The fourth category is a permanently installed standby generator or whole home battery system. These systems can monitor the grid and supply selected circuits or much of the house when an outage occurs. They offer convenience, higher capacity, and cleaner integration with the home. They also require a larger budget, professional design, and a clear decision about which loads receive backup, because whole home doesn't always mean every appliance can run without limits. Your battery may be capable of powering the house while still being completely unprepared for an electric oven, water heater, and air conditioner starting together. Apparently, appliances also believe in teamwork when it's least helpful. At this stage, you may be thinking, solar panels solve the runtime problem. They can help, but only if the complete system supports backup operation. A normal grid-connected solar installation may shut down during an outage to avoid sending electricity onto utility lines. To use solar during a blackout, the system needs compatible equipment designed to isolate safely from the grid and supply the appropriate loads. That may include suitable inverters, storage, controls, and transfer equipment. So, don't ask only how many watts of solar a product accepts. Ask how long the battery will take to recharge under realistic conditions. A battery that powers your essentials for 1 day but needs 2 perfect days to recharge may not solve a 3-day outage. Solar panel ratings describe performance under specified conditions. Your real production changes with sunlight, panel angle, shade, temperature, weather, and the charging limits of the system. Plan using conservative conditions rather than the most beautiful number in the advertisement. There's another specification that matters if you need uninterrupted equipment: transfer behavior. Some systems can begin supplying backup very quickly after the grid fails. Others require you to switch them manually or reconnect appliances. If you're protecting desktop computers, networking equipment, or sensitive devices, check whether the product's backup mode is compatible with those devices. A product described as having an emergency power function isn't automatically identical to a true uninterruptible power supply. Now let's turn everything into a simple buying process. First, list the appliances you genuinely need during an outage. Second, find each appliance's running power and identify any starting surge. Third, estimate how many hours each appliance will operate. Fourth, multiply watts by hours to estimate watt hours. Fifth, account for conversion losses and add a reserve. Sixth, decide how the system will recharge before the next outage. And seventh, choose the system category that matches your situation. If you only need phones, lights, a router, and a laptop, a smaller portable power station may be enough. If you need a refrigerator and several essentials overnight, you'll probably need more battery capacity and enough surge output to start the compressor. If you experience frequent outages and want selected home circuits powered automatically, a properly installed battery and inverter system may make more sense. If outages last several days and heavy loads are essential, a generator or hybrid system may be more practical, provided it can be operated safely. And if you want automatic whole home coverage, you need a professionally designed system based on your home's actual electrical loads, not the size of the neighbor's battery. Before buying anything, check 6 final details: usable battery capacity, continuous and surge output, charging speed, expansion options, warranty and service support, and whether replacement batteries, accessories, and qualified repairs are available in your region. A slightly cheaper system becomes very expensive when one proprietary cable fails and the nearest replacement is 3 countries away. The right backup power system isn't necessarily the largest one you can afford. It's the system that starts your required appliances, keeps them running for the expected outage, recharges before you need it again, and can be used safely inside your real home. Calculate the load, calculate the time, then choose the technology. Because the goal isn't to own an impressive battery. The goal is to stop noticing when the power goes out.